So we're finishing solving the problem that we started in the last video. So again, we're focusing, once we get the common denominator, we can just set the numerators equal to each other and go from there. So now we can go ahead and distribute. We get 9x minus 54 minus 7x plus 49 should be equal to 13. Combining like terms, we'll get 2x minus 5 equals 13. So 2x equals 18 and x equals 9. We double check, is 9 an excluded value? No, it is not. So that means it works as our solution. X is equal to 9. Okay, first thing we want to do, look for excluded values. So we'll actually need to factor this denominator first. It factors to 2x minus 1 and x plus 4. So when we think about our excluded values, if we set each of these factors equal to 0 in our denominators, our excluded values would be 1/2 and -4. We also want to think about what's our LCD. What's going to be 2x minus 1 and then the x plus 4. So following my method here, I'm going to see what piece is missing from each of my fractions here in our LCD. So the x over 2x minus 1 is missing the x plus 4 over x plus 4. The 3 over x plus 4 is missing the 2x minus 1. And then on the right-hand side, nothing's missing, so we'll just leave it the way it is. So now that I've got everything with a common denominator, I can just focus on the numerators. So that's x times x plus 4 plus 3 times 2x minus 1 will be equal to 21. Distributing, we get x squared plus 4x plus 6x minus 3 equals 21. Writing it in standard form, moving everything to one side, x squared plus 10x minus 24 equal to 0. This factors to x plus 12, x minus 2. So setting each of those factors equal to 0, we'll get solutions of x equals -12 and +2. And we want to double check, those are not excluded values. They are not. So those would be our solutions to our equation. Now, if we want to solve real-world problems with rational equations, we can use models. So we've got Kelsey kayaking on a river. She travels 5 miles upstream and 5 miles downstream in a total of 6 hours. In still water, Kelsey can travel at an average speed of 3 miles per hour. What is the average speed of the river's current? So you'll notice this is going to be a distance equals rate times time problem. We're going to do a little bit of rearranging. More specifically, we're going to get time by itself. So it'll be time is distance over the rate. So analyzing the important information. So the answer will be the average speed of the river's current. That's what we're looking for. What's the speed of the current? Kelsey spends how many hours kayaking? A total of 6 hours. She travels 5 miles upstream and 5 miles downstream. And her average speed in still water is 3 miles per hour. So if we let C represent the speed of the current in miles per hour, then Kelsey is going upstream. Her speed is equal to her speed in still water minus C. Upstream, she's fighting the current. It's going to slow her down. It's going to slow her down by whatever the speed of the current is. And Kelsey is going downstream. Her speed is equal to her speed in still water plus the speed of the current. When you're going downstream, the current is helping you out. So it would be still water plus current C. Now, the variable C is restricted to positive real numbers. Current, it's a real world situation. Current can't be negative. So for her distance upstream, she goes 5 miles. Her average speed then would be 3 minus C. And her average speed going downstream would be 3 plus C. Now, we don't know how much time that's going to take. So we'll have to take that equation. Time is distance over rate. So time here would be our distance, 5 over 3 minus C. Time here would be 5 over 3 plus C. So if we write our equation here, our total time should be equal to our time upstream plus the time downstream. So total time is 6 our time to go upstream was 5 over 3 minus c, and our time to go downstream was 5 over 3 plus c. So first we want to look for what are the extraneous values, the excluded values. Those would be at 3 and negative 3. And our LCD would be 3 minus c times 3 plus c. So if we multiply each of the terms by the LCD, 3 minus c, 3 plus c, 3 minus c, 3 plus c, 3 minus c, 3 plus c, and then divide out the common factors. So again, we multiplied everything by the LCD. So those 3 minus c's will go away there. The 3 plus c's will go away there. So 3 minus c, 3 plus c is actually a difference of squares. So it will become 9 minus c squared. Here we'll have 5 times 3 plus c, 5 times 3 minus c. This will give us 54 minus 6c squared is equal to 15 plus 5c plus 15 minus 5c. So solving this out, we can move everything to one side. We'll end up with 6c squared minus 24. This factors to 6, and then c squared minus 4, which is a difference of squares. C plus 2, c minus 2. So those are our factors here. We set each of these equal to 0. We'll end up with values of c is negative 2 or c is positive 2. So there are no extraneous solutions. The solution is c is equal to negative 2 or positive 2. However, c is equal to negative 2 is unreasonable because the speed of the current can't be negative. Remember, speed is a real-world situation here, can't be negative. But the solution c equals positive 2 is reasonable because the speed of the current can be positive. So if the speed of the current is 2 miles per hour, it would take Kelsey 5 hours to go upstream and then 1 hour to go downstream for the total of 6 hours. So why does the domain of the variable have to be restricted in real-world problems that can be modeled with a rational equation? Variables must make sense in the real world, like current can't be negative. So variables must make logical sense in the real world. Okay, one more example that's very similar to that one. Kevin can clean a large aquarium tank in about 7 hours. When they work together, they can clean the tank in 4 hours. So if you think about Kevin's rate, the rate he can clean at by himself would be 1 over 7. He can clean one tank in 7 hours. So that's his rate that he can clean by himself. Laura's rate, we don't know what it is. She can clean one tank in a certain amount of time. We're not sure. But we know together, we take Kevin's rate times whatever time plus Laura's rate times whatever time. We should get one complete job. So if we think about our LCD here, it's going to be 7t. So our time we know together, it would take them 4 hours. So Kevin's rate is 1 over 7 times the time of 4 plus Laura's rate. Laura's rate is going to be our 1 over time because we don't know how long it would take her by itself. And then times the time they cleaned, 4 hours to get one complete job. So now we'll have to multiply everything times the 7t, the LCD. So that'll give us 28t over 7 plus 28t over t is equal to 7t. Solving this out, you should eventually come up with t is equal to 28 over 3, which is about 9.3 hours, or 9 hours and 20 minutes for Laura to clean the tank by herself.